Hello and welcome. I'm George Crump, lead analyst with Storage Switzerland. Thank you for joining us today. Today we're going to be talking about software-defined storage, kind of why it's not lived up to its promise, frankly why in some ways it's broken, and then also give you some ideas on how it could be fixed. The key areas we're going to focus on today is why the SDS is so hardware inefficient and how this inefficiency really limits your hardware choices, which of course is the whole idea behind software-defined storage was to open up those hardware choices. And then also how that inefficiency forces specialization and you end up with an SDS solution per workload. So we're going to cover those today. Joining me on the webinar to help with the conversation, we have a customer, Bruce Lewalt. Bruce, why don't you tell the folks a little bit about yourself and what you guys do?
Sure. So I put together a team of really smart people to help me start an AI system for salespeople, helps automate a lot of the things they do and make them more effective. And we deal with just unbelievable amounts of both structured and unstructured data. And so I went through this journey of, thinking originally we were going to put this all in the cloud somewhere. And then when we did the cost and what that really cost, I was blown away. And so we started looking at doing it ourselves, having our own system. SDS seemed like a great idea. But when I started doing the numbers, I just experienced some of the things you're going to talk about today. So I'm here to talk about somewhat of my journey just from the practical standpoint, and we'll talk about that more later.
Great. Yeah, and I'm sure the viewers are going to enjoy that real-world perspective. So also joining us is Michael Finkelstein. Mike is with Store One. Mike, thanks for joining us today. Why don't you tell the folks a little bit about you and Store One?
Yeah, so I've actually been with Store One, and I've been helping them sell to enterprise customers from a wide range of industries, anything from higher education through financial services. And what we've been doing is really finding ways to help our customers create more customized solutions based on our software. And we'll go more into how flexible the solution is and why they're able to do that from anything from software through to hardware.
All right. Thanks, Mike. So for those that don't know me, I'm George Crump, founder and lead analyst at Storage Switzerland. We've been an analyst firm now for 11 years. Prior to that, I was CTO at a large storage integrator designing primarily high-performance storage systems. So back in the old days, these were DRAM-based and then evolved into flash. And then also I did a lot of work around data protection and disaster recovery, implementing and monitoring several disaster recovery plans. So let's kind of jump into the meat of the presentation here. I always like to start with a level set on whatever the topic is. Obviously today's software-defined storage. So software-defined storage is the concept of abstracting the hardware and software from each other. And so in this case, what we want to do is take the storage software, you can almost call it the storage operating system or operating environment, pull that away from the hardware, and then it should allow you to then run your storage software on anybody's hardware. And the idea being that, you kind of get some benefits from that. You can, in theory, choose anybody's hardware. You can use commodity hardware. You can sort of centralize under a single management structure. And so some of the problems that SDS were trying to solve were first of all, cost, right? So we were always trying to reduce the cost of storage. The second was, and part of that cost is driving out the cost of high performance storage, right? So not necessarily focused on extracting more performance, but driving down the cost of performance. And then the second area was to sort of give you a single, if you will, operating environment for your storage infrastructure so that you don't have to go from vendor A to vendor B to vendor C's console to implement a variety of features. And so those are some of the things that we see today, or that was kind of the goal of software storage. Like I said before, the primary thing was to eliminate hardware lock-in. And to some extent, it achieved some of those goals, but what we see is vendors really kind of coming back into hardware. So, and we'll talk about that in some more detail in a second. The other idea was to lower physical and operational costs. I kind of talked about that a little bit. In theory, you should be able to buy commodity hardware as well as have a centralized console, which gives you that centralized, if you will, storage operating environment for the entire data center. So those are sort of some of the goals of software-defined storage. But what we're seeing today is software-defined storage adoption is really quite low. Most data centers that I visit today are still buying what I would describe as a branded solution where the hardware and the software comes from the same vendor. If there is a software-defined storage project in flight at the organization, it's like a pilot project or very specific to a unique point use case. It's sort of, in its own little world and not used broadly. And even if you, to some extent, you could describe some of the hyper-converged solutions as software-defined storage solutions. But what we typically find is that these are also only used for point projects. One of the most prevalent uses of hyper-converged solutions is for virtual desktop infrastructure. So we don't see the sort of broad adoption in either of those situations. And like I said before, it's really the turnkey system, that name brand product that's delivering hardware and software to the customer, that continues to sell and sell real well. So I think it's fair to look back. If you look at the promise, if you will, of SDS, it's fair to kind of look and say, hey, why didn't this take over? I mean, SDS is one of those things, I call it a great whiteboard technology. If you draw it up on the whiteboard and we're in a room of IT professionals, everybody goes, wow, that's great. I can lower my hardware costs. I can use anybody's stuff. But then it doesn't execute real well. So let's talk about kind of what went wrong and where we are right now from the state of the art. The big challenge is that most software-defined storage solutions have what I would describe as an efficiency problem, in that they're not efficient. They require just as much compute as dedicated systems, and in many cases require more compute than dedicated systems. One of your larger bill of materials when you're putting together a storage system is the cost of that CPU. And so the fact that you're still required to go get a relatively high-end, if not a very high-end CPU to drive that software is really a limiting factor. And if you think about what we're doing, depending on the type of software-defined solution here, right, we've got a software component that has to interface with a CPU, and then that CPU has to interface in some manner, either SAS or NVMe, with the storage technology. And so the more time that CPU has to spend working on the software and working through if you will, the algorithms in the software, the less efficient the solution becomes. And so that really drives a lot of challenges as we kind of go through this. And like I said, the other thing that's interesting is it requires just as much storage hardware as dedicated systems, even when we start to talk about flash. Most systems require X number of flash drives to achieve some measurable level of performance. And if you do the raw math on the flash drives, you're not getting anywhere close to what the raw capability of the flash drive is. And so why is this? Well, very simply, many solutions don't really take advantage of multi-core processors. In the world of IT, you've got to be very, very careful that you are playing chess, and in many cases, the vendors are playing checkers. And so when they say, okay, we've got multi-core support, checkbox, you need to say, okay, yeah, but I'm playing chess, and look at that and see what they mean by they're using multi-core processors. In many cases, if they're doing it at all, they're just putting a specific task on each core, but they're not, if you will, striping across the cores and using those cores as if you will, as a team. And as you guys know, nowadays with some of the server technology, we have plentiful cores available to us, and so there's only so many things you can dedicate to a specific core. So that you got to be very careful, really ask those questions and understand what they're talking about when they start mentioning multi-core support. The second thing is they count on open source or public domain code for a lot of the features, right? So we see this a lot, whether it's in some cases they're building the entire system right off of an open source file system or open source block, and they're not even, if you will, trying to deny it, or they're pulling, if you will, libraries of specific functions, right? And the challenge with that, not that that's necessarily a horrible approach, the problem is you just lose efficiency, because you got to remember all that code and those algorithms were written in an entirely different era, where we didn't have flash, where we didn't have multi-core processors. And so what you really need to do is kind of think about that and probably rewrite those algorithms for modern architectures. And so I mean, a fair question is, well, why don't vendors do that, or why do vendors pick this sort of open source public library of features? Well, it's very much a speed to market thing, right? I mean, if you're going to rewrite, for example, a rate algorithm from scratch, that's going to take you a little while. And so it delays your entry to market. Most vendors are under pressure to not only get to market, but to begin producing revenue as fast as possible. And so the easier approach is to make the customer buy more powerful processors and use existing architectures. So that's kind of one of the things we see. The other one that we see, and this one's rampant, I describe it as a workload problem. Most data centers have a need really for three types of workloads, right? There's a sort of random I/O workload that would be, your classic databases, virtual infrastructures with high numbers of virtual machines, which probably within there are also databases. And then increasingly there's a demand for sequential I/O, so like a streaming type of application. That could be either streaming out or streaming in. And we see even in, if you will, traditional data centers, that demand increasing. By the way, backup is a really good example of a sequential workload when you're streaming a bunch of data to a single device. And then there's a third demand of just capacity, where you don't want to delete this data. You need to retain it either for a legal or business reason. And so you just need the ability to have it sitting there cost effectively but accessible. So the challenge you see then is that most software-defined storage solutions can't mix multiple workloads within the same software. Some will allow you to, if you will, tune them, but you tune out the other use case, right? And so what ends up happening in many, many cases is data centers end up buying multiple software-defined storage solutions for each workload type. It is not uncommon at all for us to go into a data center and see a SDS solution being used for transactional I/O, another one being used for the virtual infrastructure, typically probably some sort of a hyper-converged solution, then still another one being used for a sequential I/O workload, another, if you will, subcategory within sequential I/O is that backup or data protection workload, and then a third is sort of this repository or this retention concept, and again, that's another workload. And I'm not necessarily saying that there's this magic piece of hardware that you can put all this stuff on one box, but even if you had, and if I just described 4 workloads there, even if you had 4 different storage systems, there would be immense value in having the same storage software operating across it, right? And so the value of being able to do that is tremendous, just from a training perspective and processes and procedures capability. And so what we see though is this fragmentation by workload, and usually sub-fragmentation even within the workloads, and each of those all have unique hardware with unique software, and so the whole thing becomes essentially a mess. What we've seen surveys, and I can just from our anecdotal visits can back this up, that indicate that the average mid-sized data center and larger has at least 6 different storage vendors in the data center today. You know, I grew up in an era where the whole goal was to get you guys down to 1, and now we're at 6. So apparently we weren't very good at that. But you know, so that really becomes a key challenge as we sort of move along here. Now, another thing to keep in mind is cost, right? A key factor with software-defined storage, or a key, you know, promise, if you will, was that it was going to drive down the cost of storage. One of the ways it should be able to do that is enable the organization to use commodity hardware, right? Commodity is a dangerous word because you could use a lot of different ways to describe it. In most worlds today, what that means is a piece of hardware that doesn't have somebody's logo on it, but still has really expensive guts, right? So the outside, the sheet metal is cheaper, but the guts are all still made by Intel and people like that, right? And so while you may be paying less for the physical hardware, so to speak, it's still a premium versus what you can do. And so there's 2 aspects of this, and this kind of ties back into that efficiency thing. If I can get the same performance on that same commodity hardware, but the guts of that hardware are also less expensive, not because they're lower quality, but because they're not as, I don't need the performance of a high-end Intel processor. I just need either a low-end or mid-range processor. And if I need, you know, a third as much RAM than some of these solutions do, that can dramatically drive down the price. Even in networking, if I could take full advantage of the network connection both internally and externally, that means less network ports, which has really a cascading effect as far as saving money and bringing greater value. And the other area, of course, is, you know, I talked about the workload problem. One of the cost issues with that is you have the need now for a variety of different software solutions, all of which need to be paid for, support needs to be purchased, and upgrades need to be done, all that kind of good stuff, as well as the hardware. So you have this kind of variety of costs associated with that, and the net result is this really increases both the physical and operational costs of the solution. And what we see in most of our research is that software-defined storage solutions don't really dramatically move the needle from a cost perspective. They are less expensive than, you know, say the number 1 or number 2 hardware vendor in the market, but so are all the other tier 2 storage solutions. So if I compare software-defined storage solutions to sort of the tier 2 turnkey solutions, and this frankly is one of the reasons why turnkey solutions continue to sell, there's really not that much of a cost difference. And you know, I'm assuming everybody on the phone's a human, and as humans, we're going to want to, if there's no perceived cost savings, why take the risk in introducing multiple vendors, right? And so instead, what we need is there needs to be a compelling enough cost difference in software-defined storage to say, okay, that makes sense. Now I'll go buy this commodity hardware because now I have the potential to save lots of money, right? And so that sort of becomes a real key component of the decision-making process. And really, each of these problems are not standalone. They're all very interrelated, right? The efficiency leads to the hardware cost issue, which, you know, so all of that really, and that leads to the fact that the delta between a software-defined storage solution, today's software-defined storage solution, and a turnkey hardware solution from a second-tier vendor, it's just not that great, right? And so you end up with this sort of unique scenario that people really need to walk through. Now, what we think needs to happen, and it's a term that we call holistic SDS, or holistic software-defined storage. It's really the next generation of software-defined storage. And what we're doing here is taking a clean slate approach to storage software and really storage software development. And this is a challenge because what you're asking the vendor who would deliver the solution to do is slow down. Now, we don't live in an industry that lends itself well to slowing down. And by slowing down, I'm saying slowing down as far as its entrance to market, is take the time and rewrite the code from scratch to take full advantage of today's multi-core processors. And remember, while we'll see minor increases in per core speed, most of the processing power today and into the future will be by us jamming, or not us, but Intel jamming more and more and more cores onto that single processor. So if you don't fix this now, the problem just gets worse. The second thing is to really take full advantage of memory-based storage. Again, the classic software-defined storage or Generation 1 software-defined storage solutions really were written in a hard drive era, and you just do things differently with memory-based storage like flash drives than you would with hard drives. And so specifically customizing the code to take advantage of flash-based storage is critical, but at the same time, you don't want to exclude the use of hard drive storage, right? To some extent, you want the same software to be able to get full performance out of an all-flash array and maximize the capacity of a hard disk-based array, because that's that capacity solution. The other is to write algorithms like RAID from scratch. And I picked RAID on purpose because that's something that I don't think a lot of people think of as something you would rewrite, right? It's been with us forever. But just because it was there forever doesn't mean we have to keep using it. So changing the data protection strategy to deliver similar or better protection with, say, faster rebuilds on less CPU and less memory would have a lot of benefits to you guys as you're selecting a solution. So looking at those, and you know, when you get into talking about rewriting algorithms like RAID and how you calculate snapshots and all those different things, this takes, well, A, smart people, and B, it takes it takes time, right? You've got to be able to deliver that. And again, I think that for the bulk of companies, these solutions really need to be internally developed by the vendor, right? So the vendor needs to take the time, look at how snapshots are applied today, and ask the question, can we do it better given what we know today? And again, I want to hit this point hard, but things have changed. You don't write code like you used to in 1990, right? You don't develop things like you did. We have just different things that code is going to run on. And so to use the same stuff that we used in 1990 or even 2005, it doesn't make a lot of sense compared to where we are today. And so really it's almost a call out to the industry to say, hey, guys, stop it. Let's start from scratch and figure out a way to do this better with the realities we have today. And so we think this sort of holistic SDS is really the way to get there. And here's what I think we see is a holistic SDS, because it would be more efficient, delivers true hardware freedom. I know that every software-defined storage vendor on the market says you can use anybody's hardware. It's usually quickly followed up by, in parentheses, as long as it's on our hardware compatibility list, which almost always leads them to want to deliver the hardware with the software. And what they'll tell me is that's what you guys want, right? Well, the reason you guys want that is because the cost of them delivering the hardware isn't that much different than if you went out and sourced it yourself. Well, and that's because the limitations of what hardware you can select are so small. So if you really open that up and you can run the software on mid-range type of boxes or even low-end in some cases, that really changes things. By the way, it also makes it really easy to evaluate. You could download the software, put it on a leftover server, and at least get a really good taste of how the environment will perform. The other key thing is maximum performance. Bruce is going to talk about a real-world example, but if you look at the delta between the raw performance of flash technology, on a per drive basis, versus what the typical storage system all flash array is delivering is a night and day difference. And so we're just not getting maximum performance out of the drives. And I find that somewhat ironic, since all we're doing is things to make the drive go faster, right? And with each thing that we improve, the net improvement is really incremental, and we're sort of getting to a point of diminishing returns. If you look at, for example, I would challenge you to go look at vendors who have been in the market long enough that they've had all flash arrays built on SAS and are now delivering all flash arrays built on NVMe. And there's unquestionably a performance boost there, but that performance boost is kind of negligible. It's nowhere near what it should have been. And in almost every case, if you look very closely, what really changed is the differences between the two boxes are bigger CPUs and more memory, right? And NVMe, right? And so it's really hard to figure out how much the real impact of NVMe would be in that case. Also, this raw, the ability to be efficient, deliver raw performance, and to run on just about any other hardware really allows you to run multiple use cases. At that point, if you can run at max performance of the internal technology, the use case is driven by what you put inside the server in terms of media more so than the software. And so it allows a single software application to be used throughout the entire environment. So you can almost think of it kind of like what VMware did from a hypervisor perspective. What you really want is a software layer that can lay across multiple hardware and use it correctly. And so what you end up with then is sort of this single storage environment for the data center. So again, using the VMware comparison, and if you're a Hyper-V or whatever guy, you can put that in there as well. But the concept of putting this foundational layer that can manage the subcomponents for you, and then you just choose those components as you see fit. Now, Bruce, I'm going to bring you into the conversation here, because what I'm really kind of excited about here is you're in the trenches out there, and you had this exact problem. So let me go ahead and bring you in, talk about kind of your journey and what you guys are doing now.
Yeah, thanks. So, it's just fascinating. I just wish you'd done this 6 months ago. Why now? Because this was a real struggle for us. We, of course, like everybody else, we were going to do the cloud, and then we realized that the economics of that don't make any sense, because we deliver data in real-time, actionable intelligence in real-time to salespeople while they're doing prospecting and making presentations. So the cost is astronomical. So then we started looking at stuff, and I'm a show-me guy. I said, I don't want to see it in your system where I can't see the system. Bring it out, install it in my data center and show me. Well, as you can imagine, some people had real heart attacks, and it turned out, George, this will be amazing to you. Some software-defined storage actually wasn't all that software-defined. Right. They really needed the hardware as well, and those people had heart attacks. So, but then they would come out, and they would, I said, okay, just, 6 SSDs, let's see what the performance. I mean, I'm not, that bright a guy, but I know what it could do. You should be able to get 600K in IOPS. And again and again and again, what would happen is that we would only get like 60. And there's a whole bunch of hand waving. Now, I train salespeople for a living, so I know when they go into cognitive overload and when they start making stuff up. And in the real world, you won't do whatever. It just happened again and again and again. And it turns out it's this legacy problem that you just described. They built all their stuff on legacy software, so they couldn't do it. Well, I did the same thing with Store One, and I was really pleasant. They were getting very near the theoretical max on just, average, regular drives. So that was pretty exciting. So the question is then to really understand how they did it. And that's where they did everything you were talking about in terms of holistic. And for us, that's really important, because we have to be able to mix and match hardware. Data is a competitive advantage. Processing is a competitive advantage for us. And so we've always got to be on the forefront of using the latest stuff. And when I looked at most things, even though they're software-defined storage, I had to like pick drives and stick with them. You know, this is insanity in this day and age. And so Store One allows us to do this. Now we got Mike on the phone too. I'm going to ask him to, because this, when I saw this, you know, I just had goosebumps when we did this demo. So Mike, come in here, and Mike's from Store One, and just tell us what's going on in this screen here.
Yeah, so here you can see actually in our UI, it gives you the ability to see all of the different drive types, their capacities, and the vendor that provided those drives. And you can sort all the way on the right side. You can actually sort it by SSD or HDD. And what it allows you to do is see, especially on the screen, you can see that we mixed a couple of different vendors in there with a whole different bunch of drive sizes. So what we're allowing you to do in this case is use all of the drives to their full capacity, and even though they're not the same, we don't need that because the software and the hardware are separated. What we've allowed you to do is really unlock all of the different vendors and use whichever vendors you prefer. So that's another way that we're allowing our customers to save.
Cool. Well, thanks. The other thing that was important to us, I mean, I'm paranoid by nature, so I put stuff in the most secure data centers, and those things are expensive. You know, footprints expensive, and so you know, legacy systems, they were big, and this, because of the performance, I could get things on a much smaller footprint. So, Steve, if you wouldn't mind, you know, I went over this real briefly, but explain just a little bit more about what's really going on here, why, you know, people aren't able to get to the maximum, and you guys really are able to get to the maximum.
So what we did differently here was, instead of building on top of the legacy software that George spoke about earlier and adding layer on top of layer to the point where, you know, we've seen solutions have, you know, tens of layers just to do simple processes, what we've done is we've simplified it down to a single layer. And because of that, it's increased the efficiency almost tenfold. And what that's really allowed us to do is now take the full advantage of the hardware that the customers already pay for. So by taking advantage of the hardware that they already have and that they've purchased, there's no need to keep increasing what they purchase and having them buy more and more and faster hardware just to get the increase in performance.
Cool. Yeah, that was pretty exciting to see. So then the other thing is, and well, maybe I'm a control freak. I don't know, George. Everybody knows my situation.
Control aficionado.
There we go. That's it. That's it. Control aficionado. Okay. Can you tell that to my kids?
Yeah.
Okay. All right. So, you know, I want to be able to see everything, and I just don't want to have to go to 6 different systems. And so I was really kind of blown away when I could see everything that was going on in a single screen. People like to use this word, single pane of glass. I kind of like that. And so that's what we're able to do. Instead of, you know, we have structured, unstructured data. We have all kinds of different protocols and workloads. And I want to see it all in one place. And so Store One was able to do that. And it's pretty fun. Now this screen, I hope everybody can see this. I blow up your screen or something, because it's just amazing, the information that's on this screen. And Mike, do us a favor here, point out some of the key things.
Yeah, so here you can actually see that we let you choose whether the volume is going to be block, file, or object. You can change the protocols that you're using. If it's CIFS, NFS, you can change the connectivity to iSCSI or whatever else you'd really like. And what we really want to show here is just how flexible the solution is. You can create a custom volume to whatever your needs are. There's no need to set up a whole new array. And what this allows you to do is really manage all of your storage under the single pane of glass, even through an iPad, actually. And what this has allowed our customers to do is it's given them greater flexibility to actually meet the needs of their organization in a far more consolidated environment. Instead of having to go out and build those, 6 different environments for all the different use cases, they can use this singular environment and meet all of the needs.
Cool. And I like this next screenshot because this actually is a screenshot of a kind of an iPad situation here. I probably can't read it, but it's fun that you could do it on that. So tell us just a little more about what folks are seeing here.
So here you can actually see that even on a volume level, we can provision the exact performance of the volume. So if you have something that's like a data analytics volume or something that's high performance compute, you can allow it to use more of the performance from the hardware. And if you have some application that's just running in the background that you really don't want to use all of your performance, you can just limit it and put it down to 20,000 IOPS, and it'll run plenty fast for whatever that application's needs are, but it also won't take over all of your other mission critical applications and take away resources from those.
Excellent. So one of the things that we do is we, for sales teams, we analyze tons of data to figure out the personality and the needs of a customer they're going to call on. And then we actually build prospecting plans, decks for presentations, and provide them in real time. So if you can just think for a minute about what goes on to do that, it's incredible amounts of data transfer back and forth, analysis, just unbelievable amounts of things are going on. And we can never be down, and we can never be slow, because the salesperson can't wait, a presentation can't wait. And so I did a lot of load testing, and I was pretty much disappointed with most of the things we tested. But then, Store One, that stuff is just lightning fast. And George talked about this before, about why that is, about really being able to use the full value of multi-core processors and, of course, modern drives. But I thought maybe here, if you wouldn't mind, Mike, just explain really what's going on here with this problem of choke points, and that it really explains why I wasn't getting the performance that I really needed. So help people understand that. And of course, George went over this as well.
Yeah, so here, as you can see, the drives, the SSDs, they can get anywhere from, they should be getting about 100,000 IOPS each. And on the networking side, you can get anywhere from 10 to 100 gigs per second. And the question for us was, we saw a lot of the customers just weren't seeing that performance. They were getting anywhere from 20 to 60,000 IOPS, and they weren't getting the full advantage of all the hardware that they just purchased, and we realized that that's a huge inefficiency. So what we did was we recognized that the software was really the bottleneck in choking all of the performance out of the hardware. So what we've done is we've actually opened that up, and by taking the 6 years to rebuild everything from the ground up and use very different methodology, we've allowed that whole pathway to really open and give it full wire speed revolution, just like networking. And it's allowed us to get almost the full spec of all the hardware.
Wow. Yeah, that was really impressive when you did that for us. So and then, like everybody, well, I don't know if everybody, but anyway, a lot of people I know, we're really looking at NVMe, and we, it's always, when I saw those installations, they have huge numbers of drives, but we wanted to be able to do it also on a small amount of drives. So we did a test that was very similar to what you see on the screen here, with just four drives. So, again, tell people what's going on here and what kind of throughput you're getting, because I think if you didn't see this on the screen, I don't think you'd believe it. And again, I encourage folks, do a test drive. Have people come out to your location on your stuff with your data and test this stuff. Anything else, it's just too easy to fake. But it's in your data center and it's real. So anyway, I might give us a little insight here.
Yeah, so here what we did was we took 4 NVMEs, and we really, the first thing is we're one of the few storage vendors that can actually manage NVMEs at this point in time. And the reason why we thought that was very important was because we wanted people to be able to utilize the latest hardware and get the most out of it. But here what we did was we took 4 of those NVMEs and we used them with our system, and we got almost 900,000 IOPS, which for just 4 NVMEs was truly incredible. I mean, most of the other demos that we've seen, they were using, 10, 20 plus NVMEs. So by doing this demonstration, we were really able to show people the efficiency of our product.
Cool. Hey, and I want to let everybody know we're going to open this up to questions in a few minutes, so be thinking about what you want to ask. By the way, all the technical questions, they all go to Mike. not answering any of them, so I don't make it wrong. But let's finish up with this, Mike, and that's data protection. I don't know anybody that isn't concerned about this. And when we looked at it originally, we had it, people come up and say, oh yeah, we've got it on, oh, by the way. And I always get scared when they say, oh, by the way, because it was always, oh, by the way, something else that's going to cost me a lot of money, put something else in. And you guys really build data protection into the system, which was remarkable to me. So if we look at this, the screen here about data protection, it's pretty amazing what you do. So Mike, if you wouldn't mind, just walk people through this, because I think they'll be really amazed.
Yeah, so what we really focused on was ensuring that our customers' data would be fully protected throughout all points that we were actually going to be responsible for it. And so we realized that one of the largest issues was maintaining persistent integrity and making sure that customers can recover all of their data with zero loss. So by having this persistent integrity, it's really allowed us to recover from almost any hardware issue. And from the disk side, you can choose the amount of redundancy and disk failures per volume. So what that allows you to do is say, hey, I have some very mission critical applications here, and I want them to have, 4, 6, whatever it might be, disk failures. And if you have something like an archive running in the back that you really don't want to take up any, additional space, you can, lower that number a bit. And because of the way that we do our rebuild, you actually get a significantly faster rebuild since we use all of the drives involved. We don't have all of the drives feeding a singular drive. All of the drives really come together and rebuild in a significantly faster way. And in terms of the snapshots, so what we've done is we've integrated unlimited snapshots into our solution. And the reason for that was we really didn't want to limit our customers. What we noticed on the market was that a lot of solutions out there limit how many snapshots customers can use. And we didn't want to do that because we said, hey, it's the customer's data. They should have full control of it, and they should be able to really, use it. And if we can't, we should be there and ensure the data protection is built in. So all of these functions are available across any of the use cases, whether it's a high performance compute environment, data analytics, or even just a traditional environment that's for every like every other company. But yeah, so we've really built it in, and we've decided that that's one of the core features of our product, and we wanted to ensure that our customers are able to protect their data with the utmost protection.
Yeah, thanks. Yeah, it was really important to me. This is kind of fun. They did this for me. I went, no, but this they'll show it to you. It's real. It's quite remarkable. So, and this is, I don't know if people can see this, but you can see. Well, go ahead, Mike. I don't want to just explain what people are seeing here, because I'm not sure it's big enough. If you're watching on the phone, to tell the magnitude of what's going on here. And then I'm going to turn this back over to George, and we'll get to questions.
Yeah, so here what you can see is that we've actually allowed you to display all of the snapshots on a calendar view. So we found that this makes it significantly easier for customers to find what they're looking for. So they can go back to any specific date, and once they click on it, they'll actually be given all of the snapshots that were taken on that date down to the second. So by going all the way down to the second, they were actually able to pick the specific snapshot that they're looking for and go right back to it. And you can do it on the snapshot on a volume layer. That's kind of what you see on the left side there. But we've really tried to make it as intuitive and easy to use as we could for all of the customers, and we've worked with them tirelessly to make sure that the UI was as intuitive as possible for everyone.
Thanks. So I'm going to finish up here and turn it over to George. For those of you that are like me out there, I just encourage you to think about two things. One that I've said a couple times here, just make sure people bring stuff out, test it in your environment with your data. No substitute. And the second is to think about things you could do that you never thought could be done before, that having this kind of capacity, this kind of power, you can do amazing things. I mean, people that, that have apps that they're coming to you and they want to be able to run and you've turned them down before, now you can almost give them their own environment and say, go to it, go for it, do stuff. Marketing, marketing, they always want something, right? More dev. You can give them the ability to do that. So think about all the amazing things you could do if you had this kind of capacity, and storage became just incredibly cheap and yet very, very fast. So I'll wrap up my part here, and George, thanks for letting me be a part of this. So I'll turn it back over to you for questions, which I see there's a bunch of.
Yeah, they're flowing in. So the really interesting conversation. I appreciate both of you guys taking the time to do that. I do want to echo Bruce's comment about testing and bringing stuff in. You got to be very careful with brochures, right? And there's nothing better. And I'm not a big fan of benchmarks and things like that, although they kind of serve a purpose. But there's nothing better than running it in your environment and seeing how it works. And I think one advantage of these sort of holistic SDS solutions is it's more practical to do it. You could bring it in on you could try to make it not look good, and if it's written correctly, it will still look good, right? So it's kind of an interesting scenario. So the couple of things here, just some housekeeping items. This webinar, I've already got some questions about this. This webinar is available or will be available on demand. It's usually available about 5 minutes after we end the live presentation. The same URL that you use to access the live event automatically becomes the URL for the on-demand event. In the upper right-hand part of your player, there's a email this button. So if you have a colleague or associate that you think might benefit from this presentation, email them a copy of this, and I'm sure that they would much rather get an email from you than from me. The other thing I want to point out, some of you guys have already taken advantage of this, but on the below on your player there's an attachments button, and there's all kinds of attachments available to you that have details on the various things that we've talked about today, and also a paper that we just had recently completed, What is Holistic SDS? That's available as well, so feel free to download those. No additional registration or anything is required there. Last but not least, we'd love feedback. As you exit the webinar, there's a feedback option. You can give us a star rating system. Somebody said that we were cool, so I guess my mom's watching. And so anyways, a star rating system there, 5 stars being the best, so feel free to rate us as you see fit. There's a little comment section, so you could further call us cool if you wanted to. And then anyway, so there's all that. So guys, if you guys are ready and up for it, let's take a look at some of the questions here. Mike, if you go through and prioritize a couple of those just so we can get to the ones that you want to, that make the most sense for you to answer, that'd be good. Here's a good one. So how much work is it to install the software? So I guess say somebody gets the copy of the software, downloads it or whatever, and they need to get it up and going. How much time do they need to allocate for this?
So that's actually a great question. We've actually had some installations take as little as 20 minutes. It's very easy since we managed to separate the software and the hardware, so there are very few hardware requirements actually, and it's about a 20-minute process without any hardware, real hardware dependencies. Just a couple of spec options.
Okay. So when I made a comment earlier about that you could kind of take a retired server and get started with that, am I stretching it a little bit there, or is that a reasonable way to get started?
Yeah, we've had customers do that. We've had customers say that they have their old Dell production server lying around, and they'll plug it back in for us, and we'll go to work on it.
Awesome. Okay, that's great. Let's see. How does NVMe work with SDS? So what are you doing anything special for NVMe or what?
Yeah, so it works really well for us right now, and we're one of the few that are actually able to really use it And we've been seeing amazing performance and almost zero latency. And we've gotten, well over in the millions of IOPS just through our NVMe testing, as, you would expect from the new utilization of like such a high performance device.
And my assumption would be, Mike, that as you guys, as technology advances, and we see things like NVMe and future specs like that come out, and we see more powerful processors, that efficiency starts to really pay off even further, and sort of that gap between you and the other guys should widen. Is that a fair assessment?
Yeah, we're actually hoping to keep the solution as flexible as possible. So as new things come out in the market, we're really looking to be one of the early adopters and come in there and be at the forefront of the new technology that's out there. And we can really do that because of the separation that we've kind of created between the software and the hardware. It makes it much easier for us to take advantage of all of the new developments on the hardware side.
Okay. So this question has actually come in probably two or three different forms, talking about using Store One as backup. And I think that's an interesting approach, right? Is you could start, if you will, you're going to do an evaluation first, but the first sort of real world test would be to use you guys maybe as a backup solution, and then over time move it into production. You want to talk a little bit about how that would unfold?
Yeah, so we do a full suite of data protection, and we get this question a lot, and we're a little surprised by it because we include everything in our solution. So we're like, hey, if you guys want to just use it for data protection, like you can, but we include everything, so we might as well take full advantage of that. We give you all the unlimited snapshots. It's included in our solution. It's baked in there. We're not going to charge you extra for it. It's there, and we allow you to set the redundancy on a volume level, which really, we haven't seen that many other people that are doing that right now. So what it's done for us is it's given us this full suite of data protection that the customer is truly able to take advantage of. And by doing so, they're able to reduce a lot of the associated backup costs with getting another vendor to do their backup and have, multiple solutions. So we've kind of consolidated all of that, and we really want to make sure that we are the holistic solution and we have everything in there.
Okay. So here's a gentleman that apparently has taken Bruce's advice and wants to test it in their environment. So the question is, do you have a way that I can try it out?
Yeah, so we're always open to letting people try it. So, anyone who's a qualified applicant, we're more than happy to arrange for them to do a free test drive. And we'll help them through that process. It's pretty easy. But we're always happy to, let people come and test it. A lot of people, they say, wow, this looks really great. Okay, can I get my hands on it now? So we have a really easy process for that, and we actually look forward to having plenty of more people trying it out over the coming months.
Yeah, and by the way, I just want to chime in here. That word "free," that's real important. No, buy it, and then if you don't like it, you can turn it back. It's a big deal to me.
All the paperwork. Right?
Yeah, right. Yeah, bring that thing up, set it up, set those drives up, make it work, and don't charge me anything. Let me really see.
So, Mike, another question here. I talked about the importance of being able to support multiple use cases. And so obviously, to some extent that means you got to provide block, file, and object. And so the question here is, what's the benefit of having block, file, and object on all the drives and using all the drives? You want to talk about that a little bit?
Yeah, so George, as you mentioned earlier, a lot of systems today, people need, in order to meet the needs of their organization, they're going to have, at least 6 systems going for all of the different types of storage that they need. So what we've done is by giving block, file, and object on the same drives, it gives the customer a lot more flexibility and allows them to adapt to the needs of their organization as it grows and the storage needs change. And one of the other benefits is you're not going to have an environment where, let's say your block environment is running out of storage, but your file one says, hey, I still have an extra, petabyte less than me, you don't run into that issue where now you're switching drives around, reformatting things. You're really able to just say, hey, I need another volume here. I have the storage, I have the space, and it makes things just much easier to manage.
Okay. So, Mike, why don't you go ahead? We've got time to maybe answer a few more questions. Why don't you go ahead and prioritize some more of those that are in there? While he's doing that, I wanted to put up the contact information for the two companies. Storage Switzerland's information is on the left-hand side, and Store One's contact information is on the right-hand side. So the next question, Mike, is I can start using this. Or can I start using this solution for backups and then slowly move it into production? Is that right?
Yeah. So again, this is kind of what I tried mentioning a little earlier, where you can use it as a backup solution. That's not really an issue for us. We're more than happy to do that, but it's kind of like buying a whole cake and only having half of it. You want to get the full you want to get everything that we offer, and by purchasing it, you get all of the performance, you get all of the features. They're all in there. It's a one solution that we really want to be your only solution. We want it to be the one that does everything for you and gives you all of the benefits and features that you're looking for.
Okay. So, Mike, we've probably got time for one more question. I'm going to go with this one because I think it's probably going to give you a good way to summarize as well. Because there was a question that came in that said, I joined late. Can you go ahead and repeat everything you said so far? So no, but the good news is it's available on demand. So as soon as we're done, about 5 minutes after, use the same URL and you're good to go. Anyway, so Mike, can you clarify what, I remember you saying this earlier, talking about single layer versus multi-layer. Can you clarify what you mean by that again, please?
Yeah, so what that's really referring to is how the legacy SDS solutions, what they've done is they build on top of each other. They haven't, in the past 15, 20 years, they really haven't taken the time to rebuild things from the ground up and take advantage of all of the new advancements that we have with modern hardware. So what we've really done here is we've consolidated all of those layers. We've rebuilt all of them, and we have almost 50 patents on doing that. And what that's allowed us to do is really get the full advantage and performance and features that the new hardware is able to give us. So by consolidating all of those layers into a single layer, what it's given us is this vastly more efficient solution.
Okay, perfect. Appreciate that. That's obviously where the efficiency comes from. So we're just about the top of an hour, so we'll go ahead and wrap it there. Bruce, thanks very much for sitting in today, and thanks for having me. No problem. And Mike, thanks for your help on the technical aspects of the conversation.
Thank you.
And I want to thank each of you for joining us in the live presentation, and if you're watching us on demand later, also thank you for that. If you are watching us on demand and you do have a question, we don't want you to feel left out. So just tweet us questions at Storage Swiss, refer to this webinar, and we'll answer you directly. You could also, my email address is right there, which explains why I get so much spam, I guess. But you can also email me directly any questions you might have about this presentation or the things we talked about, and I'll be glad to answer you as best I can. So anyways, for Bruce and Mike, I'm George Crump, lead analyst for Storage Switzerland. Thank you for joining us today. Have a great rest of your day.